So if you're anything like me, you see the start of this video and you go, that's a lot of steps. Don't worry about it. I love this method. This method's really nice. You're going to love this method too. That's a lie. You may or may not love this method, but let's do it and learn it anyway. Just like last time, we're going to start with the example and just do steps one by one. But I don't have that many colors, so we're going to clump up the colors. Steps 1 and 2 will be blue. Right, both equations with the variables on one side and the constants on the other. That's exactly what we have right here. Step 1 is already done. The variables are on one side, right? These are the variables, they're all on one side. The constants are all on the other. Okay, great. Step 2, write one equation above the other, lining up the variables. Great. This is going great. We don't have to do anything. So that's what this is talking about, right? It wants the variables to be lined up. So, and we'll see a little bit more about what that can look like in later problems. All right, let's go to the next step. Step 3, multiply one of the equations or maybe both of the equations so that there's a variable that has opposite signed coefficients in both equations. This one looks confusing. This is a hard, weirdly explained. I want these coefficients to be opposite of each other. One is 2x. I would want the other to be negative 2x. Or maybe one is 5x and the other one's negative 5x. Or it doesn't have to be x's. It could be the coefficients for the y's. We just want the coefficients to be opposite. So the question is, what do we have to multiply these equations by so we can get some opposite coefficients? Now, this is a little weird because 2 is kind of hard to, we'd have to multiply this by 2.5 or negative 2.5 to get it right. So let's try to get the x's to match up, or the y's. It doesn't matter. Oh, which doesn't matter. So what I'm going to do is, let's see. Well, I'll multiply this equation by 5. And this equation by negative 2. I'm choosing those numbers because now if I do that, we'll have a 10x, right? If I do this, we'll have a 10x right here. And we'll have a negative 10x right here. Okay? And this is just kind of a weirdly phrased instructions for step 3. But all the idea is that we're setting it up for the addition step. It'll make more sense when we get a little further along. So if we do step 3, what do these equations become? We multiply everything by 5 for the first equation. That gives us 10x plus 15y equals negative 80. And the second equation becomes negative 10x plus 20y equals negative 60. So the reason why we do that step 3 is so step 4 is super easy. Step 4 says we add both of these equations together. So this is our step 4, is we just add these equations together. And the reason we can do that is because for an equation, we can always add something to both sides of the equation, right? We can add 5 to both sides. We can add 2 to both sides. We can add 3 to both sides. We can add any number we want to both sides of the equation, as long as it's the same thing on both sides. You might be saying, well, Jason, we're not adding the same things on both sides. The left side, we're adding this, and the right side, we're adding this. But they are the same. They look different, but notice that they are equal to each other. Negative 60 is the same thing as negative 10x plus 20y. So we really are just adding both sides of the equation. We're adding the same thing to them. So when we do that, and we add these two equations together, we now have 0 x's. That's nice. No more x's to worry about. Plus 35 y's. On the right-hand side, negative 80 plus negative 60 is negative 140. We don't even have to write 0x, right? 0x is nothing. That's gone. So all we have to do is now solve this equation for y. I might be getting ahead of myself. We've done step 4. Step 5 says solve for both. Great. solve for the remaining variable. So we'll divide both sides by 35. We're going to get that 1y is equal to negative 4, I think. Great. Step 6, substitute your answer of y equals negative 4 into either original equation to find the second variable. So we can substitute into this top equation or this bottom equation. It's your choice. I'm going to choose the top equation because it has smaller numbers, and I like smaller numbers. So we know that 2x plus 3y equals negative 16, and we know that y equals negative 4. And the reason why it doesn't matter which one we plug it into is because this is a system of equations. They both have to be true. So plugging into one should equal the same thing as plugging into the other. They need to be the same thing or we wouldn't have a solution. So if this is the case, then we know that 2x plus 3 times y, we said y is negative 4, is equal to negative 16. And we just simplify and solve. 2x minus 12 is equal to negative 16. Add 12 to both sides, we'll get 2x is equal to negative 4, or x is equal to negative 2. Our solution is x is negative 2, y is negative 4. That's our solution. We can check our answer. And again, if we plug in both of those x's and y's, we should get that both equations are true statements. Should get negative 16 equals negative 16, and positive 30 equals positive 30. All right. So now it's your turn. Oh, I gave myself extra white space on the next page, but I forgot I had it. So anyway, solve this equation by addition. So pause the video, try to do this one on your own. Similarly to last time, we already have all the variables on one side. We have all the constants on the other side. And yeah, everything's lined up more or less. It's more or less lined up. You could line it up a little bit nicer if you wanted. So last time we had to multiply both equations by something. And what I choose for multiplying is not going to be the same as what you choose. But again, step 1 and step 2, they're already done for us here. Step 3 is multiplying. What I see is that I can just multiply the second equation by 7, and that's it. Because if I multiply the second equation by 7, look at the two equations that we get. We get 2x minus 7y equals 2. Nothing changes for the first equation. And when we multiply the second equation by 7, we get 21x plus 7y equals negative 140. Be very careful to remember to multiply the right-hand side as well. Okay. Make sure this guy gets the 7 as well. Whatever we do to one side of an equation, we have to do to the other. So that's step 3. And this is really nice because now our x's aren't going to cancel, but when we add our equations together, the y's will cancel, right? So we can do step 4 and add these equations together. When we do that, we're going to get 23x's and 0y's equals negative 138. Looks a little weird. Hopefully we're good though. And now we can go to step 5, which is just solve for the remaining variable. We're going to divide both sides by 23. When we do that, we get x is equal to, I think that's negative 6. Pretty sure. We'll check our answer at the end. Great. And now we can use this with either equation. So I like the second equation. It's pretty simple looking. And we can use the original one too. So 3x plus y equals negative 20, and x is negative 6. So 3 times negative 6 plus y equals negative 20. That's negative 18 plus y equals negative 20. Add 18 to both sides, and you're going to get y is negative 2. Let's write our answer down and see if we're right. X is negative 6, y is negative 2. Let's check. Call this our first equation and this our second equation. Our first equation says 2 times x minus 7 times y should equal 2. I'm writing the question mark because I don't know if it's equal. I'm hoping it is. And if we do that, we get negative 12 plus 14. Is that equal to 2? Oh, yeah, it is. Nice. So if it satisfies the other one, if the other equation's true, then we've got ourselves a real solution. The other equation says that 3 times our x plus 1 times our y should equal negative 20. Well, that's negative 18 minus 2. Does that equal negative 20? It does! Hooray! I know, it's very exciting. Everyone's very excited. All right, that's our answer. So those are the 3 ways that we're going to talk about: graphical, substituting, substitutional, substitution, and addition. And they each have their pros and cons. So for the rest of this section, we'll have a bunch of different systems. We'll solve them in different ways, depending on what's kind of appropriate. So I'll talk more in future videos about when to use which one. Stay tuned until next time. I can't find the stop recording video button.